This video goes through notes 7-2, so please make sure that the substitute has, or the stamper has given you credit for finishing assignment 7-1. If you did not get that credit, if you do not speak up for yourself right at this moment, then you will not get credit and you'll just have to live with the late grade later. So we have our assignment 7-1 from yesterday talking about similar polygons. Remember that similar polygons are polygons with the same shape but different sizes. So we started with this assignment. Please take a moment to check. Pause now if you need to check 1 through 10 as I'm about to move on. So here's problems 11 through 16. Please make sure you take a quick check. 17 through 19 are shown up above. Please make sure you take a quick check. 20 through 22 are shown up above, or shown here. Please take a quick check. 23 and 24 are shown here. 25 and 26. 27 and 28, 29 and 30. So we're about to transition into notes for today. So if you do not have your notes out yet, please make sure you have those out and near you. We are going to be taking notes for 7-2, so make sure you are ready for that. So remember from yesterday, similar polygons are polygons with the same shape but different sizes. So they look similar. They're not congruent because they're not exactly the same, but they are similar, like puppies and dogs. So puppies kind of look similar to dogs. They look like the smaller version of their parents, okay? So they've asked us to determine if these figures are similar, justify our answers. So if we want to look at angles, because angle is something you can use for similar polygons, then we could find this missing angle right here. So we have 90 and 37 and x, and we know triangles all add up to 180. When we solve, we find that x is 53. So this angle right in here is 53 degrees. Over on the other triangle, we have this one. We'll call it y since it's in a different triangle. And we have 90, 53, and y, which would add to 180. We could solve for y and get that y is 37. So these have the same angles. Also, if we look at our ratio, so from this side to this side, 9 to 6 has a ratio of 3 to 2. Bottom 3 to 2 is obviously that same ratio, and then 18 to 12 is the same ratio of 3 to 2. So these two figures are similar because they have congruent angles and the corresponding sides have a common ratio. So sides have a common ratio. So those two pieces are there. The angles are the same, and if the angles aren't the same, they can't be similar. And the sides are congruent. The congruent sides have a common ratio. So in this next example, example 4, they tell us this time they are similar. So those pieces should be the same. First, they want us to complete the following. So if we do our congruent statement, A, B, C, D, or our similarity, I should say, E, F, G, H. So we line them up. So E is congruent to A. Angle A is 60 degrees. So E would be 60 degrees. B is congruent to F. So B and F are the same. So B would be 100 degrees. C and G are the same. Both of them are labeled. So G is congruent to 90 degrees, or angle G equals 90 degrees. And then D and H are congruent, and they are both unknown in both polygons. So in order to figure out this missing angle, I would need to do a little bit of math. So I know that polygons add up to 360 degrees. I know 60, 100, and 90 are already taken, and then the missing would be angle H or angle D. Doesn't really matter depending on which polygon you're looking at. So if I were to solve for this, 60, 100, and 90 would be 250. And then take away 250. And angle H is 110 degrees. And angle H is also congruent to angle D. So we completed those by using our congruence statements. Then they ask us, what is the common ratio from ABCD to EFGH? So we're putting ABCD first. So if we want to use the bottom one, because that's the only piece we have for both. See, if I look, I have 5 but unknown, and 9, 21 and unknown. So the only one I have both in is the bottom, 6 to 18. So 6 to 18 is the same thing as 1/3. So my common ratio is 1 to 3. So ABCD is basically multiplied by 3. So ABCD has a ratio of 1 to 3 for quadrilateral EFGH. Then they asked me to find the following. So using that 1 to 3 ratio, they want me to find EH. So I'm going to erase some of this beautifulness I got going on here because there's a lot in this picture. So if I look at EH is this line right here, and it's congruent to 5. So remember, my ratio is 1 to 3. I have 5 on the top and an unknown on the bottom. So 5 times 3 is 15, 1 times x is 1x, so e to h is 15. Remember, e to h, or this one, should be 3 times bigger than the other one. Then BC over here, this one should be smaller, so I have an unknown y and 9 with the other one. So I have small to big, unknown small, 9 for the big. So 1 times 9 is 9, 3 times y is 3y, divide by 3, and y equals 3. You could also say it's 1/3 of the size of 9. And then up at the top, E to F, A to B are congruent. So I have 1/3 as my ratio. We don't know the small, but the big is 21. So 1 times 21 is 21, and 3 times z, divide by 3, and z equals 7. So I think it is best if you set up ratios, small to big, or ABCD to EFGH, but you can also say this is 1/3 as big or 3 times as big if you see that visually. If you don't see that, please don't try to take the shortcut. The ratio will work every single time, so let it work for you. So example 5, they tell me the lengths of the sides of a triangle are in the ratio 3, 5, and 7, and the perimeter is 120 degrees. Find the length of the shortest side of the triangle. So we have a triangle with sides 3x, 5x, and 7x. That's my ratio. Now remember, it does not mean those sides are 3, 5, and 7. It means they have a ratio of 3 times x, 5 times x, and 7 times x. So whatever this piece is 3, this is 5, and this is 7, and it's all in relationship to x. The total perimeter is 120. So how do we find the perimeter of anything ever? Exactly, we add all the sides. Thank you for answering my question out loud. So 3x plus 5x plus 7x equals 120. So 3 plus 5 is 8 plus 7 is 15x, and that equals 120. I divide both pieces by 15, and x equals 8. Now pay attention. What was the question? The shortest side. If they'd asked for x, I'm golden, I can move on. But they want the shortest side. So my shortest side is going to be 3 times whatever, because 3 times the same thing that 5 times and 7 times, 3 is going to be the smallest. So remember, x is the same thing. If you feel the need, you could plug x into 3x, 5x, and 7x, find all of those, and then determine it. But I promise, multiplying one thing by 3 and that same thing by 5 and the same thing by 7, multiplying by 3 is always going to be the smallest. So 3x is my smallest, 3 times 8 is 24 centimeters, and that would be my smallest. If you needed to do a quick check, you could plug in x here and here as well, add them all up, and make sure they add to 180. So example 6, we have a triangle with the ratio 1, 2, and 3, and they want, measures of the angles. I apologize. Got to go inside. 1x, 2x, 3x, and they want to know the measure of the largest angle. Now, if you notice, they didn't give us anything to add it up to, but we are not fooled. We know that all triangles add up to 180 on the inside only. The angles add up to 180, so I could not do this if this was on the outside. And I have all my inside angles, 1x, 2x, and 3x, that are going to equal 180. So to simplify, this would be 6x equals 180, and x equals 30. Now I double check what they asked for. Oops, they wanted the largest angle, not just x. So my largest angle is going to be 3 times x. So 3 times x, 3 times 30 is 90 degrees. So I technically didn't draw that triangle correctly because it should be a right angle for that 3x. Okay? You have the rest of class to work on your assignment 7-2 with ratios. Please do not distract others. This is not helpful for anybody. Don't distract others. We got a Thanksgiving break coming up. You have 4 days of work you need to put in. You've already put in 3.5 at this point. So finish strong for today, because you only have 3 days left after this until Thanksgiving break. So work hard. I am okay with you listening to your music, as long as it is not distracting you and we aren't just playing on our phones. That's a phone, Obvi. Okay? So I expect that you are not playing on your phone until you finish your assignment. After you finish your assignment, you can play on your phone all you want, as long as the ultimate goal of not distracting others is still happening. Please behave very well for these very nice teachers who are covering for me, and let them know that you are on your best behavior as a thank you from me as well. I'll see you guys tomorrow.